Okay, in this next section here, in the last section that we're actually going to cover in Chapter 8 of trigonometry here, is we're going to talk about angles of elevation and depression. Okay, so this is largely application-based problems using information that we've already learned. Okay, so in our prerequisite skills here in the warm-up, it asks us to identify the pairs of alternate interior angles, right? So alternate, earlier this year we talked about how alternate is just going to mean opposite, right? And we're talking about opposite sides of the transversal, right? We talked about this other word, interior, which is basically, again, that fancy math word for inside. Okay, I guess it's not just a math word, but it is a math word, okay? Inside, right? So alternate, again, we have our parallel lines here. We can see our parallel lines are marked by our arrows here, okay? So we're looking at now our transversal, which is just the line that intersects our two parallel lines, okay? And we're looking for the angles or the pairs of angles that are on the opposite inside, opposite sides of the transversal inside of the parallel lines, okay? And so it looks like angle 2 and angle 7 are inside of the parallel lines and on the opposite side of the transversal. So I can say that angle 2 is congruent to angle 7, okay? And the other pair of alternate interior angles would be angle 6 and angle 3, okay? So we can say angle 6 is congruent to angle 3. Okay, in the next part, all right, it asks us to use the calculator to find the tangent of 30 degrees to the nearest hundredth. Okay, remember in class we said this is going to depend on the type of calculator you have, but in mine when I type in the tangent of 30 degrees, I get 0.58 as my final answer here. So 0.58, when I round it, that's going to be the tangent of 30 degrees. Okay, and then finally, the last part says, if we have the tangent of 54 degrees equals 2500 divided by x, we want to solve that and we want to round it to the nearest hundredth. Okay, so I'm going to rewrite this so I can kind of work this around a little bit using algebra. So tangent of 54 degrees equals 2500 over x. Okay, again, I'm trying to figure out x here, so I'm going to try to move the x out of the denominator here by multiplying both sides of the equation by x. Okay, I know that x over x will cross cancel there, so I'll have x times the tangent of 54 degrees equals 2500, right? And now since x is being multiplied by the tangent of 54 degrees, I will divide by the tangent of 54 degrees on both sides of the equation. Okay, tangent of 54 over the tangent of 54 will cancel there. That divides to 1, and so I'll get x equals 2500 divided by the tangent of 54 degrees, okay? And that is going to give me 1816.36 is my final answer there, rounded to the nearest hundredth. Okay, so again, these are just skills that obviously are going to play into what we're going to learn today with angles of elevation and angles of depression. So again, our objective for today is to solve problems involving angles of elevation and angles of depression, okay? And obviously the vocabulary that we'll cover is talking about, you know, what exactly is an angle of elevation and what is an angle of depression. Okay, so looking at this here, it says an angle of elevation is the angle formed by a horizontal line and the line of sight to a point above the line. Okay, so it says in the diagram, angle 1 is the angle of elevation from tower T to plane P. Okay, and so let's take a look at this, right? So it says angle 1 is the angle of elevation, right? So this is the horizontal line that we're looking at. Okay, notice how there's another horizontal line to the plane here. Okay, and this angle, again, from this person, okay, that's sitting in this tower, it goes all the way up that line of sight to the plane. Notice how it's above that first horizontal line, right? It's above, and it goes here. So that's an angle of elevation, right? Because again, it's above that dotted line there, okay? If we go ahead and look back, okay, it says an angle of depression is the angle formed by a horizontal line and a line of sight to a point below the line, okay? And so this angle 2 is the angle of depression of the plane to the tower. Okay, so if we look here, again, from the plane, again, this is the horizontal line here that represents the height of the plane, right? And again, the line of sight goes down from the plane to the tower, right? So that's actually depression, right? Okay, so that angle 2 is an angle of depression in this case. Okay, now what we have to understand about this particular picture, okay, it says since the horizontal lines are parallel, okay, angle 1 and angle 2 are congruent by the alternate interior angles theorem. Okay, again, these are parallel lines right here. Okay, these horizontal lines. This is our transversal from T to P. So that means that angle 2 and angle 1 are actually congruent. Okay, so again, it says therefore the angle of elevation from one point is congruent to the angle of depression from the other point. Okay, so it's really important that we remember that. Okay, so again, you may want to go back, check out these videos again of the introduction. Okay, but now we're going to start going through some application of these particular problems, making some drawings, and again, this should be actually a pretty fun lesson.